In this video, I'm going to show you what I like to use to fill out the unit circle. There are actually lots of patterns you can implement on this or try to memorize. I'm just going to be going over the way I think of this and reason it out myself. It's a lot better than trying to memorize the numbers. Focus on the patterns that are being employed here. So the first thing I like to do is fill out the degree measurements. That's one of the easiest things to do. You should know that the degree measurements start on the right-hand side. So this is our starting position going straight to the right. And you'll notice there are two blanks. That's because we're going to start here, and then as we go all the way around, we'll also write down what that angle is after going all the way around. So we're going to write that angle twice. That's why there are two blanks with a degree measurement symbol on it. So our starting point is here at 0 degrees. Now you'll notice there are actually only two gaps for the angles that we're measuring. There are the bigger gaps, which are 30-degree gaps, and then there are these smaller gaps, which are 15-degree gaps. So you really only need to be able to add those two numbers if you want to fill in all the degree measurements going all the way around. If we start at 0, every time we see a big gap, we're going to add 30, and every time we see a small gap, we're going to add 15. And you'll notice they also always occur in pairs. So when you're writing these out, it's always going to be like plus 15, plus 15, plus 30, plus 30, plus 15, plus 15, plus 30, plus 30, etc. The only thing that's weird is that we do start in the middle of one of the gaps. So I'm going to add 30 for the very first angle. And then this is a small gap, so I'm going to add 15. And then add 15 again. Big gap, so add 30. Big gap, add 30. Add 15 for the small gap. Add 15 again. 30. 30, 15, 15, 30, 30, 15, 15, and then one last 30, because like I said, we want to also describe what that angle is after going all the way around. So the last one, we call this 0 or 360 degrees. So that one we're giving two names. That's why there are two blanks for the degree measurements. Next, I like to go in and I like to fill in the radian measurements. Now, it's helpful to remember that 30 degrees, if you convert that to a radian measurement, you'd be multiplying by pi over 180. So this is essentially a pi over 6. So this gap right here, this larger sized gap, could also be described as counting off increments of pi over 6. So one thing I like to work out on this is if that's a 1 pi over 6, this is 0 again for 0 radians. So if that's 1 pi over 6, every time I see that larger 30-degree gap, that's going to be another pi over 6. So I can just reduce the fractions going around. So I have 1 pi over 6. Well, two of the smaller gaps combined makes another 30 degrees. So that's 2 pi over 6, but we want to reduce our fraction. So 2 pi over 6 is equal to pi over 3. And then this one would be another big gap, so that's 3 pi over 6, but that fraction can be reduced. And then 4 pi over 6, reduced. 5 pi over 6 does not reduce. 6 pi over 6 does reduce. 7 pi over 6 does not reduce. 8 pi over 6 reduces. 9 pi over 6 reduces. 10 pi over 6 reduces. 11 pi over 6 does not reduce. And then 12 pi over 6 reduces. So I was just recognizing that every time I have a big gap of 30 degrees, I know to hit those lines with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. So I'm kind of just counting off 1, 2, 3, 4, 5, 6, 7, all the way up through 12, and then I'm reducing the fractions. Whenever I can reduce the fraction over 6, I do that. Now you'll notice we didn't fill in every angle measurement with that. We got almost all of them. So the other angle measurement that might be helpful to remember is that 45 degrees, if we convert that one, would be equal to 1 pi over 4. So a pi over 4 increment, that would be 45 degrees. So that would be a big piece and a small piece combined. So basically this pattern is going to hit all of the x and the y axis tick marks, and it's going to hit all of the ones going in the middle of each quadrant. So every time you have a big piece and a small piece combined, There's a shortcut. That's the ones on the x and the y axis, and the ones halfway between, in the very middle of each quadrant. That's going to be the same kind of pattern, but now I'm going to be counting by pi over 4 pieces. So it's going to be 1 pi over 4. The next one would have been 2 pi over 4, but we already filled that one in and reduced it. I just need to remember that that's the 2 mark. The next one would be 3 pi over 4. And then 4 pi over 4 has already been filled in and reduced. So next is 5 pi over 4. 6 pi over 4 has already been filled in. 7 pi over 4. So using those two patterns, you can fill in all of the radian measurements. And if you're ever in doubt or worried that you might have miscounted, you could always just pick one of the degree measurements and convert it the way we did here. I usually just think of those two and then count off the pattern going around, but you can always convert every single one if you want. It just takes a little while to compute those over and over and over again. And after a while, you'll start to just memorize the angles, even in radian measurement as well. So we filled in all of the angles in both degree and radian mode. Now we want to talk about these ordered pairs going around the outside. So for these, I want to remind you of what the triangles we looked at were on the previous worksheet, the reference triangles worksheet. So we talked about how if you have a 45, 45, 90, that means the base of your triangle is going to be root 2 over 2, and the height of your triangle is going to be root 2 over 2, assuming that the hypotenuse is 1. So what's happening is these sides and heights, the base and height of your triangle, makes your x and your y coordinate. Well, all 4 of these dots are going to have the exact same numbers for x and y, minus the fact that some of them have negative signs on them. I like to ignore the negatives and fill all of those in at the very end. So what I'd like to start off just by recognizing is the ones that go right through the middle of each quadrant, the ones we just looked at for the radian measurements, those will all use the numbers root 2 over 2 and root 2 over 2. So I go to the unit circle and I fill in the ones going through the middle of each quadrant. I ignore the plus or minus signs for now, and I just fill in root 2 over 2, root 2 over 2. And then I do the same thing for the middle of this quadrant. And then I do the same thing for this quadrant. And the same thing for this quadrant. Again, I will come back and I will do the negative signs at the very end. Okay, so next let's talk about the ones that have the short height and the long base. These were the 30, 60, 90 triangles. So when we have 30 as the central angle, it made a height of 1/2 and a base of root 3 over 2. Well, all 4 of these dots, basically the ones that are closest to the x-axis, the ones that have the short heights, will all use the same numbers, root 3 over 2, 1/2. So I do the same thing. I go back to the diagram, and I just fill in the ones that are closest to the x-axis. So this one will be root 3 over 2, 1/2. It's got the bigger x value and the smaller y value. This one will be root 3 over 2, 1/2. This one will be root 3 over 2, 1/2. And this one will be root 3 over 2, 1/2. All 4 of those triangles will have the same x and y values. Okay, the patterns continue. The central angle of 60 also makes a pair with 1/2 and root 3 over 2, but this time it has flipped the x and the y value. Now we have a smaller base and a taller height. So it has flipped and put the smaller number for x and the bigger number for y. So these are going to be the numbers that are closest to the y-axis. The ones that are taller have a bigger y value. So now I just use the same numbers, but I flip the order of them. So 1/2, root 3 over 2. And so these are hitting the lines here, 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 and here, the ones closest to the y-axis up and down. So 1/2, root 3 over 2. 1/2 root 3 over 2, and 1/2 root 3 over 2. We have almost filled in everything. The last numbers that we need to fill in are the ones that are actually on the x and the y axis. So these are the ones, if we're dealing with a unit circle which has radius 1, going straight to the right will be the point 1, 0. Going straight to the left will be negative 1, 0, but I'll come back into the negatives. Up and down gives you a y value of 1 instead of an x value of 1. So now I can just fill in the ones going left and right are 1, 0s. The ones going up and down have a y value of 1. So the last thing I do now, I ignored all the negative signs until I got all the ordered pairs written in. Now I just like to go through and think about what makes an x value positive or negative. Well, if the center of my unit circle is the origin, x values are positive when you move to the right. So all of the ones on this side will have a positive x coordinate. And then they are negative when you go to the left. So all of the x coordinates will be negative on this left-hand side. So now I can just go through and make all of the x values negative. And then I do the same thing for the y coordinates. Y coordinates are positive when you go up. So all of the y values on top are positive. They are negative when you go down. So now I can just fill in the second number in each ordered pair will be negative for all of the ones on the bottom of the unit circle. And so I wasn't able to get the numbers to fit in on the parentheses I provided there, so just to fill in the ordered pairs there, that is my fully completed unit circle. Now I didn't do the tangent values. We'll talk about those another time. Those do just come from taking your y coordinates and dividing by your x coordinates. But there are some other patterns we can learn to memorize and fill those in later as well. That's it for the degree measurements, the radians, the x and the y coordinates.